Hello, this is for the ZEREK Education platform.
Simplify the expression, the fraction of a cubed minus b cubed over a minus b. We'll use the difference of cubes identity, confirm it numerically with a quick check, and then build an intuitive visual using a graph for a specific choice of b. First, recall the difference of cubes identity. A cubed minus b cubed equals, parentheses a minus b times parentheses a squared plus ab plus b squared. This factorization is the key to simplifying our fraction. Now, apply that identity to the numerator of our fraction. We get parentheses a minus b times parentheses a squared plus ab plus b squared, all over a minus b. Because the factor a minus b appears in both the numerator and the denominator, we can cancel it as long as it is not equal to b. The simplified result is a squared plus ab plus b squared. And remember to note the condition, a not equal b, because the original denominator cannot be 0. Let's quickly check with numbers to build intuition. Take it equals 5, and b equals 2. Compute the left side, 125 minus 8, over 5 minus 2 equals 117 over 3, which is 39. Now compute the right side. A squared plus ab plus b squared equals 25 plus 10 plus 4, also 39. So the simplification is consistent. For a visual, let's set b equal to 1 and think of her as x. We'll compare the function y equals the fraction x cubed minus 1 over x minus 1 with its simplified form y equals x squared plus x plus 1. These two match everywhere except at x equals 1, where the original has a hole because the denominator is 0. This picture shows a removable discontinuity. The simplified expression fills in the missing point with value 3 at x equals 1. To summarize, the fraction of a cubed minus b cubed over a minus b simplifies to a squared plus ab plus b squared for a not equal b. Always remember to check the domain when canceling a common factor from numerator and denominator.